This Indramat Servo drive has intermittently powered up with the Alarm 71. Alarm 71 is no 10 volts on the current sense circuits. Over here is the power supply section. I'll show you my drawings at the end of the video of what I've drawn out here. But I found something very interesting. There's two switching MOSFETs right here. And I'll show you on the scope here just in a little bit. But they're switched from this PWM IC, this switch mode power supply IC. I'll get my close-up glasses on, I'll read you the part number. It's a UC3825DW. And when I put my scope on here, if I just gently put my scope on the tab of these MOSFETs, I don't see the switching waveform, but it goes up to, thereabouts 20 volts on the scope. And if I press down, then I see the waveform. I'll show you what I mean here. Connect to ground here. Just turn that on. There's the waveform. There's the waveform. That's what it should look like. It's going to come up good every time now because I'm trying to show you what I saw. There, look at that. There it is. See it flatline at 23.9 volts. Isn't that amazing? I can make it fail. If I press down on the tab of that MOSFET, either one, I can make that fail. I think I've got a bad connection here. I'm going to fire up the soldering iron and I'm going to solder those mounting screws down to the board on the other side. We'll take a look, see, we might have a broke connection right there. Power that down. Let's get disconnected. We'll flip it over to the other side there and see what it looks like. Now, this is what the waveform should look like. When I press down on the tab of that MOSFET, it flatlines at 23.91 volts DC. That's not good. We need to fix that. Let's take those off. I'll lift them up a little bit if I can. We're going to shine up the other side with some sandpaper so we'll have a good electrical connection. Scuff up that pad right there. Then we'll scuff up the back side of the MOSFETs. The lands and grooves that were driving into the metal will make a better connection. And then solder these back down. on the other side. Hopefully, this will fix that alarm 71 alarm. Here's where those two screws come through the tab on the board. We're going to solder that screw to the board. That should do it. Let that cool off. Still doing it. Looks like I might have a crack in the board. If I put my probe gently down on there, I've got a good waveform. Watch this. Push down on this corner of the board, I lose my waveform and it flatlines at 23.9 volts DC. It's interesting. Got something going on with that board. Well, we got our work cut out for us today. It's going to be hard to find. We'll get it though. We fixed it. We fixed it. That's it. All right. It's not dropping out anymore. Okay. Looks like we had some busted vias. Fix that with the wire wrap wire from gate to the 25 ohm resistor, 24 ohm resistor, and then reflowed the solder on the pins of the UC3825DW, and that fixed it. Okay, we can put this back together now. fixed it. Hello all, here we are at the house, and we're going to look at the circuit that we repaired that was intermittently causing alarm 71 on the Indramat Servo drive. Now the first thing I did was I cleaned the tabs with sandpaper and joined those tabs for better contact to the board by soldering the backside screws to the board, but that didn't fix it. So the next thing we did was we reflowed the solder on this UC3825DW. And then we joined output A and output B of the UC3825 to this 24 ohm resistor and the output of the 24 ohm resistor to the gate of those two MOSFETs. Now the MOSFET part numbers are IRF 640. And one side, you'll notice that all of these transformers are in parallel. And one side is connected to this MOSFET. And the other side of the transformer is connected to this MOSFET. And both MOSFETs are connected to that power board ground right here and right here. The center tap of each transformer is connected to 24 volts, as well as the cooling fan connected to 24 volts. And when the MOSFETs are turned on, current flows through the transformer. And these MOSFETs are switched on and off at a very high frequency. And so the output side, the secondaries, are switched because we are switching the primaries. Now down here, that same 24 volts on the center tap of each transformer goes to the cooling fan and also goes to the input of this LM317TP+, which is making plus 15 volts DC. Well, there you go. That's an amazing little circuit right there. They use one pulse width modulation IC to switch all of these transformers. Now, what are these transformers supplying out here on the secondaries? Well, this one here, and I might get them mixed up, but that's okay. This one here is making the 3 each low side voltages on the output side of the opto-couplers for gate firing of the 3 low side IGBTs. And these 3 are making the high side U, V, and W voltages for the gate firing of those 3 each high side IGBTs. This one up here is making the voltage for the control board. So with one little IC, a couple of MOSFETs, they're making all of those voltages right there. Amazing. That is amazing. Alright folks, I'll put these drawings up at the end of the video so you can look at that circuit. And have a good night. We'll see you next time. Hello all! Here we are, day 2 of this video. Now I forgot to mention, how does this circuit right here relate to alarm 71, which is the plus and minus error for the current sense modules? How does this circuit right here cause that alarm 71, which doesn't even seem to be related? Okay, we're going to take a look at the secondary of this transformer up here that's being switched by the UC3825DW, these two MOSFETs right here. This transformer, TR5, let's look at the secondary and let's follow that out. Okay, let me set this up here. I might have to adjust the video here to get a little bit closer so we can see what's going on. Here is the secondary of transformer TR5. Now we had already seen the primary side of those transformer. Here's the secondary windings of that transformer. And what we have is a full bridge rectifier circuit, center tap transformer right here, 2 diodes, a filter capacitor. The filter capacitor removes the V ripple from this rectification right here. Now look, we go from the firing board where this transformer, 2 diodes, filter capacitor reside, up to the control board. And here we have a ribbon cable. It's called XI8. And on the control board, it comes in on XI8, pins 18, 19. Here's ground, 2, 4, 6, 8, 10, 12, and 16. This is the same ground back to the center tap of the TR5 transformer. 18 and 19 through the control board run back out another ribbon connector, XI6, on pins 1 and 2. And its grounds being on 2, 4, 6, 8, 10, 12, and 16. So we route this voltage into the control board and back out the control board back to the power board, the firing PC board. Now I imagine that this voltage right here runs off into different circuitry on the control board, but I wasn't worried about that, so I didn't bother to work this circuit out right here. Y'all can do that if you get a wild hair someday and you want to see where this 18 and 19 and 1 and 2 on the XI8 and XI6 between those two connectors on the control board runs off to. Y'all do that. When you do, let me know where it goes. So we have a DC voltage here that comes onto the control board and runs back off. Well, where does it go when we run back off? Down XI6 ribbon cable connector. Let's go see where that goes. Are we still in the frame? Let me scoot this over a little bit. There we go. Here's pin 1 and 2 of XI6. Now it's plus 13.51 volts DC. I measured that from that full bridge rectifier circuit back there, created by the switching of transformer TR5. It comes into the input. We have another filter capacitor right here, 10 microfarad at 35 volts. It comes into the input of this LM317 TP+. Now this is not the same one we saw back there that was making the plus 15 volts for the UC. Let me get this out of the way. The UC3825DW. It's not the same as this one down here. This is different. This is V2 on the board right here. That takes the 24 in and makes the 15 for the supply input of the UC3825DW. This is not the same one as that one down there. This is a different one. And it takes 13. Are we still in the board? Are we still in the camera here? I got papers going this way and that way. It takes 13.51 volts DC in from that full bridge rectifier back there, and makes plus 10.31 volts DC. I measured it to power up the current sense modules. Now that is how Alarm 71 is related from no volts on the current sense modules back to that bad switching circuit that we repaired. Now, if you look down here on that same ribbon cable XI6, this 10 volts runs up into the control board on pins 24 and 26. And y'all can work this out too if you want to. I just don't have time to do that. But I am guessing that this input to the control board, you'll find a monitoring circuit that's looking at that 10 volts. And that monitoring circuit, when it doesn't see that 10 volts to the current sense modules, says, hey, we got a problem. We better spit up Alarm 71 and shut the drive down. Okay, there you go. That's how the 10.31 volts DC to the current senses is related back to that circuit that we repaired. This circuit right here. Alright folks, I think this will be the end of the video now. Alright, okay. Thank you again for stopping by. Y'all's good people. I really enjoy it when you come over to see what I'm fixing next. Have a good night. We'll see you next time.